Last class period, we spent a lot of time talking about sig figs. And remember, why do we have to deal with sig figs in chemistry and you've never had to deal with them in all the other math that you've been doing in all your life? That's because in the chemistry classroom, in a science classroom, these numbers correspond to measurements, and that's why we got to do all this sig fig business to keep track of those measured precisions. All right? So the other important part of any measurement are the units that are associated with that measurement. And so that's what we need to pick up with here today, is this discussion of units that we're going to be encountering. All right, so science has kind of laid out what we consider to be the base units, the things that we are going to be measuring in as we go throughout our experiments and such, what are called the SI base units. SI stands for System International. It was this conference that happened in France in the 70s where a bunch of scientists got together and were like, all right, we got to get on the same page with what units we're using. Because these Americans are using pounds, we're using grams, these other people are using stones. We just got to simplify things. We got to pick one system that we're all going to stick to from here on out. All right? And most of the world has since adopted that system in what's called the metric system. Here in the US, we have very stubbornly held out. There was a push in the 80s to get us to adopt it, and big business was like, nah, we're good. That's going to cost too much money. We'll stick with this other one. All right, so we're stuck with this imperial system, which is quite lesser than. So that's why the rest of the scientific community has adopted that metric system. So the units that we use are going to depend on what exactly that we're measuring. So we'll have different units if we're measuring mass. We talked about mass today, right? How heavy or how light something is. Or we could talk about the volume of a substance. What is volume? The amount of space that's occupied by that substance, right? Yes, that's the volume of that substance. We could measure distance or length, all right? We also want to measure temperature. And a lot of interesting chemical properties depend on time. So we're going to have an SI base unit for that as well. All right, so these are these different quantities that we could be measuring here. All right, for mass, our base unit is going to be the gram. And for that, we use this lowercase g to represent grams. For volume, our base unit is the liter, capital L. Right? In the US, we're more accustomed to gallons or the cups or whatever it is. They use liters. For distance, we're going to use the meter, which is a lowercase m. For temperature, we're actually mostly going to be using degrees Celsius for temperature, but there's an even more fundamental unit of temperature, what's called the Kelvin. And I'm going to punt on why it's considered to be more fundamental until we get to our discussion of gases, but it is considered the base unit for measuring temperature. That is uppercase K for Kelvin. And then time, our base unit is seconds, lowercase s. Okay? So these are going to be the base units that we use depending on what quantity that we're talking about, or rather what it is that we're measuring. Whether we're measuring mass or volume, we would use different units, and it's going to depend on these. Rather, in science, we use these SI base units. Okay, so now we're going to talk about what are called metric prefixes. Okay, and we're just going to note these are used to denote the scale of a measurement. All right, so what do I mean by that? Okay, so what we use here in America is what's called the imperial system. All right, our feet, inches, pounds, all that jazz. That's what's called the imperial system. And in the imperial system, let's say that we are going to stick to length, just for this example. Well, if we want to measure something that's small in the imperial system, what units do we use for length? Like if I wanted to measure how wide this piece of paper was, what would be the convenient units that I would use here in America? Inches, right? That's how we denote stuff that's small, in inches. If it's a little bit bigger, like I wanted to measure how tall I was, then we would measure in feet, all right? And if we were measuring something really far, like if I was trying to give the distance to my house, I would instead be using units of miles. All right, so we have these different units that we use depending on the scale of what we're talking about. And it's always just convenience. I mean, I could tell you how many inches my house is from this place right here. It would just be some big ridiculous number that's cumbersome to work with, right? So instead we change our scale and we talk in miles. It just makes things more convenient, all right? They do the same thing in the metric system, but they'll always keep their same base unit. So if we're talking about distance in the metric system, they're gonna measure in meters. All right, they would use meters, kind of analogous to how we would use feet. So now we're talking about the metric system. All right, so if I wanted to measure how tall I was, I would do so in meters. Okay, but if I wanted to measure something small, I'm still going to use meters. And what I'm going to do is I'm just going to tack a prefix onto the front of that. All right, so for example, if I wanted to measure something small, I could do so in centimeters. Where this here, the centi, is this metric prefix. All right, so still that same base unit, I just tacked a prefix onto the end of it, or onto the beginning of it. And that prefix is denoting scale. Likewise, if I wanted to measure something that was really far away, I wouldn't use meters, I would use kilometers or kilometers. Where again, I stuck that metric prefix of kilo onto the front of that base unit of meter. All right? So that's how we do things in the metric system, is we scale using these prefixes. And the punchline, let me just tell you, is that it's so much more convenient because as opposed to converting between feet and inches where you use that factor of 12, in the metric system, they're always factors of 10. And that's what makes it a little bit more convenient and why we like it in science. All right? So first of all, this is going to introduce us to the first conversion page, or rather the first section of our constants page here. So everybody, let's grab our constants page. And really what we're interested in right now is this section right here. These different metric prefixes. All right, we'll learn how to use the different tables on this page here, but for right now, we're focusing in on this one. What's up? Yeah, right up there. So it's on the back of your periodic table. You're good. All right, so let me just grab this thing here. We're going to do some examples. Okay, so first of all, we can note we have those metric prefixes. Whoops. All right, and as we said, we have those centi. We saw in our previous example centimeters, or kilo, another one of those. I picked those because I think those you've heard of. There's some on here that maybe you haven't heard of. A femto, super teeny tiny small, right? Or a tera, super humongous, right? So there are these different metric prefixes. Some of them we've heard of before. You may have heard of like gigabytes now that we've got these crazy computers compared to what we've had in the past. But yes, these are all these different metric prefixes that we have here, okay? And so they're denoting the scale. So first of all, notice that for all of our metric prefixes, we have the prefix itself. We also have these symbols that we use. So just like we have our symbols that we have for our different units, meter was M, we also will have a symbol for our prefix. So if we go back up to our example here, wherever that was. Okay. Meter we said was lowercase m. If I wanted to do the symbol for centimeter, that would be lowercase c, lowercase m, because again on my table here, centi is lowercase c. What would be a kilometer? What would I use symbol-wise? Lowercase k, lowercase m for kilometers. All right, so again, just like we put the prefix on the front of the word, we put the prefix on the front of the symbol as well. Okay? Cool. All right, so let me show you the simplest use of these prefixes here, and then we'll generalize this. All right? So let's say that we were talking about something that was 4.75 times 10 to the 3 grams. We talked about scientific notation last class. It's not like you can't use this. It's just we prefer to use numbers that are kind of like close to small whole numbers. We don't like to use these very large numbers here. So instead, we could look on our prefix conversion table, and we could note that this prefix kilo means 10 to the 3. All right? So that means that in our measurement here of 4.7 times 10 to the 3 grams, we can replace that and make this 4.75 kilograms, where again, that kilo stands for that 10 to the 3. Let me actually just, all right, where that kilo represents that 10 to the 3. All right, and all that does is make it more convenient to deal with that unit. Now it's a nice number to deal with. I don't have this 10 to the 3 business on the back end to worry about. Okay, so using our table here, I'm going to put down a few more measurements, and I want you to put them in their more convenient units here. All right, so just like we said, we could replace 10 to the 3 with that kilo prefix, because that's what our table said. What are we going to replace this 10 to the negative 9 with? Nano. So this 4.7 times 10 to the negative 9 seconds is the same thing as 4.7 nanoseconds. All right, likewise, and again, where the nano stands for 10 to the negative 9. All right, likewise, by 10 to the positive 6, what am I going to replace that with? Mega. So this would be 6.33 megaliters. Cool? Where again, the mega stands for that 10 to the 6 business. All right? So that's all well and good. If you see a number in scientific notation, and that scientific notation happens to match exactly one of these units here, great. Very easy unit conversion. All right? But we need to make it a little bit more general than that. Okay? So what we're going to work on now is taking this table, and we're going to build these metric prefix conversions. All right? So we're going to title this metric prefix conversions. Okay, so we need to get this relationship from this table from our prefixed units to our base units. All right, so what do I mean by that? I need this relationship between, let's say, for example, centimeters and meters. And I'm trying to figure out how many centimeters equal how many meters. Okay, and we need to get that information from our table here. All right, so I'm going to tell you that this table is telling me that 1 centimeter equals 10 to the negative 2 meters. All right? So first of all, hopefully we can all see where that 10 to the negative 2 came from, because I looked up centi here. 10 to the negative 2. All right? Now, this would be true whether I was talking about centimeters, I could be talking about centigrams, I could be talking centigrams to grams, I could be talking about centiseconds to seconds, whatever that base unit is, I'm allowed to swap out, right? That's the relationship between the base unit and my prefixed unit, okay? So now let's try to do another one here. Let's say that we're trying to go from meters to kilometers, and we're trying to fill in the blanks here. How many meters equal how many kilometers? I'm going to look on my table here, and I get this 10 to the 3. So, okay, I know I got 10 to the 3. Right? But the question is, where does it go? Does it go on this side, or does it go on that side? That's the hard part. This is what everybody messes up. All right? So let's try to standardize which way we're going to build these things so we don't actually flip them around and get the exact opposite of the correct answer. Okay? So first of all, what we're going to do is I'm going to start with what I hope is a very non-controversial statement here, the idea that 1 kilometer equals 1 kilometer. Can we all agree with that? If we got 1 kilometer over here, 1 kilometer over here, that is the same thing. Okay, and then we're going to remember, what does it mean to be a kilometer? What does that K stand for? That 10 to the 3. So on one side, I'm going to replace my K with 10 to the 3. So I have 10 to the 3 meters equals that 1 kilometer. All right? Now, this, if you're really nerdy, mathy definition here, you're like, awesome. That makes sense. Great. Everybody else is like, I'm still going to mess this thing up, okay? So let's boil it down to one little simple phrase that we're going to keep in our mind to make sure that we build these prefix conversions correctly. Notice that in both of these here, the 1 is always next to the prefix, right? My 1 goes next to the prefix. The 10 to the whatever is next to the base unit all by itself. So let's just have one little phrase that we chant to ourselves where we remember the 1 goes with the prefix. All right, we're going to build our equality. We're trying to figure out what goes where. Put the 1 on the side with that metric prefix. All right. Okay, I'm going to go back to my original example here. My 1 centimeter, 1 with the prefix, equals 10 to the negative 2 meters. Well, this is all well and good, and it's 100% true. 1 centimeter is indeed 10 to the negative 2 meters, all right? But this doesn't really help us in math at all, in like doing a unit conversion here. So from here, we're gonna have to take this equality, and we're going to build a conversion factor. All right? This conversion factor is what we're actually going to use in our math. All right? How are we going to build a conversion factor? What does this look like? We're going to stack the left side, or rather, let's just make it even more general. Stack one side over the other. So my conversion factor here for this equality relationship, this right here, gets converted into this conversion factor of 1 centimeter over 10 to the negative 2 meters. All right, and for every single conversion factor that we build in this course, you can take it as is, or you could flip it upside down. So you got 2 different ways that you could use your conversion factor here, meaning I could put centimeters on the top and meters on the bottom, or I could take it and flip it around, 10 to the negative 2 meters over 1 centimeter. All right, so I took this equality relationship that I got from my table, and I made it into this conversion factor here. All right, so how's this going to be useful here? All right, these are what we're going to actually use. One of these two are what we're actually going to use in our math. But let's get an example problem down here, okay? I want to, so example, we're going to convert 4.7 centimeters into meters. Okay? So how are we going to do this? How are we going to do our conversion here? We're going to start with what's given. What's given is this initial measurement of 4.7 centimeters. So that's what we're going to start with our math. 4.7 centimeters. And now I'm going to multiply by one of these conversion factors here. I'm going to put one of the conversion factors right there. Multiply that initial measurement in order to do this conversion. All right, so how am I going to pick? With the one on the left or the one on the right here? All right. Importantly, we're trying to get rid of those units of centimeters, right? We're trying to end up in those units of meters. So we're going to specifically select the conversion factor that will allow us to cancel units of centimeters and be left with units of meters. And what do I mean by cancel? Well, just like if I had A times B divided by A, what does this equal? The A's cancel out, and I'm left with B. Same exact thing for units, right? So I want to pick my conversion factor such that centimeters are on the bottom and meters are on top. That will allow me to cancel out those units I'm trying to get rid of and leave those units of meters left over, all right? So that means which one of these conversion factors am I going to use, the one on the left or the one on the right? I'm going to need to use this one right here. My 10 to the negative 2 meters over 1 centimeter, right? And again, I know this is set up correctly because my units cancel out in such a way that I'm left with those units of meters, which is what I'm trying to jump into. Okay, so punch this into our calculator here. We would get 0.047. And there's 3 steps we always got to do for all of our problems here in our chemistry class. Step 1 is to do the math. Boom, got my numeric value at the end. Step 2, we got to apply our rules that we learned last class for significant figures. All right, so our significant figures, we got to make sure that we have the correct number of significant figures at the end here. This is going to be based on our inputs. All right, so my first input here, that 4.7 has how many sig figs? We got 2 sig figs. And what about this conversion factor here? All right, if we look very carefully on this table here, up at the top, it says all of our SI prefixes are exact. And remember what it means to be exact is that you have an infinite number of sig figs, meaning we're never limited in sig figs by those exact conversions, right? We said definitions were an example of an exact conversion. Here's the definition. The definition of a centimeter is 10 to the negative 2 meters. So this is exact. Best case scenario, I get to ignore it, meaning I just need to make sure I got those 2 sig figs in my answer, which currently I do, so I'm good. I don't have to do anything crazy here. Okay? And then the third step. So do the math, units, sig figs, last one's units. Okay? Make sure you don't have any naked numbers. You get a point off if you don't stick the units on the end. So we want to make sure we did all this work to cancel out those centimeters and leave us in units of meters. Put a box around it, final answer. Okay? Cool. All right, I want y'all to do one on your own here. Let's do 73.40 kiloliters into liters. Step 1, you're going to build that conversion factor. And then step 2, You're going to set up the math. All right, everybody take a second. See if you can't do this conversion on your own here. All right, so first of all, I got my table here. What's my equality going to be? How many kiloliters, how many liters? Where's the 1 going to go, on the left or the right? On the 1 goes with that kilo prefix. All right, which means that on the other side, I look up kilo, we get 10 to the 3. So that's how I get my 1 kiloliter is 1,000, or 10 to the 3 liters. And then this is well and good, but doesn't really help me in my math at all. So in order to use something, rather to turn it into something that I could use in my math, I'm going to take one side, 1 kiloliter over 10 to the 3 liters, or I could take it and flip it upside down. Note real quick that when I say I'm going to flip it upside down, I don't just flip the number, I don't just flip the units, you flip the whole thing. All right? Cool. So now we're going to set up the math. We're going to start with what we're given, 73.40 kiloliters, and we're going to multiply by one of these two conversion factors here. Which one are we going to pick? The one on the left or the one on the right? The one on the right, because we need those kiloliters on the bottom and liters on the top so we can cancel out our kiloliters. All right, so that's 1, 10 to the 3. So we're going to punch this into our calculator. We get 73400. Okay? Cool. So we got our math done. Now we need to do sig figs. All right, let's punt on sig figs for 1 second. Let's do the last step here, our units. What units should we have here? Liters. Okay, I wanted to do this because this is a tricky example here. How many sig figs should I have in this number? Right, so this here has 4 sig figs. This is exact, so it's not going to limit me. So I should have 1, 2, 3, 4 sig figs in this number, right? So how are we going to represent this number with the correct number of sig figs? Well, if this was an exam, you're done. Put a bar over it. That indicates that 0 is significant. Boom, done and done. All right? That's how we would indicate a 0 in the middle of a number is a significant figure. Another way that you could do this, and this works because numbers in digits in scientific notation, every digit you show is significant. So we could also say that this is 7.340 times 10 to the 4 liters. We could put it in scientific notation. This is perfectly fine as well. Okay? So either one of these, all right, let's say both, exam acceptable. I'm going to be big on keeping track of sig figs with this bar, and so if that's how you do things, especially with these zeros, that's perfectly fine. On MyOpenMath, on your homework, it doesn't have any bar that you can put over it, so it would actually just accept the answer in scientific notation, or if you just typed in this number as is, as long as it's rounded correctly, it would give it to you. All right, it's going to be like, all right, fine, I know you're trying to tell me that that has 4 sig figs. So either of these would be acceptable on your homework. On your exam, make sure you put the bar over it. All right, for me, for paper exams, you can put the bar over it. Make sure you put the bar over it. All right, cool. All right, so now let's jump. We got our metric prefix conversions. Now we're going to jump to just more general unit conversions. Okay, going to our constants page. Now we're talking about using everything over here on the left-hand side. All right. First of all, we got a bunch of different unit conversions that are summarized here in this table. Let's just note that first they're broken down by what it is that you're measuring: distance, volume, mass, energy, pressure, temperature, et cetera, right? So all these different units you can see represented here, or rather all these different measurements you can see here. So all the distance measurements would be in this category here, okay? All the volume measurements we got here, et cetera. So that's how this table is organized. So how are we supposed to read this table here? I'm going to make some room over to the side. I lied. I'm going to do this. I'm going to grab like just a little excerpt from that table here. Whoops. Cool. And so for an example problem, let's say we're trying to convert 37 inches into centimeters. All right. The process is going to be very similar to what we saw before. Step 1, we got to build a conversion factor. We got to build something that we can actually use in our math here. And this table is actually even easier to read than the previous table. All right, there's not the same sort of guesswork involved. All we got to do is we got to look. We see that 1 inch gives us the abbreviation for inches here, is equal to 2.54 centimeters. All right, so we have 1 inch equals 2.54 centimeters. And just like before, what did we do with this equality that allowed us to use it in our math? We're going to take one side and do what with it? Stack it over the other one, right? So just like before, we can build these conversion factors where I have 1 inch over 2.54 centimeters. Or with any conversion factor we use in this course, we could take it as is, or we could flip it upside down, 2.54 centimeters over 1 inch. Okay? So from this table, again, even easier to use than the metric prefixes, it tells me 1 inch is equal to 2.54 centimeters. That's my equality. And we stack one side over the other to get our conversion factors. So now, based on what we did before, I want everybody to take a second and set up the math. Do the problem for us. All right, we're starting with these 37 inches. Convert it to centimeters for me. so I'm going to take this 37 inches and I'm going to multiply it by which one of these two conversion factors? The one on the left or the one on the right? The one on the right, because that puts those units of inches on the bottom, centimeters on the top. Punch that into my calculator. I get 93.98. And what are my units? Centimeters, because I did all that work to make sure I got rid of inches, and I'm left with centimeters. All right, and then I'm done. Sig figs, everybody's favorite. Okay, so how many sig figs should my answer have? My 37 inches have 2 sig figs. What about this 2.54 over 1 business? Doesn't count. So why doesn't it count? We got to look carefully at our constants page here. If you notice, it says everything that has these double asterisks. Let me just go over here, actually. Right? Anything that has that double asterisk is an exact conversion. A lot of these conversions are, in fact, exact conversions. Not all of them, but quite a bit of them are exact conversions. And centimeters to inches is one such example. I guess this is such a fundamental example, they felt the need to include that word exactly as well, but importantly, anything that has those two asterisks. So for example, going from miles to feet, that's also an exact conversion. All right, so we will not be limited by our conversion factor. This is exact, which means our final answer, we're going to round to 2 significant figures, or 94 centimeters. Cool? All right, so again, we got this relationship from our table here. We built these conversion factors. We set up our problem. We picked which conversion factor based on which one was going to allow us to cancel those units. And that left us with our 94 centimeters rounded to the correct number of sig figs. Okay? All right, so I want you to do another one here. I want you, let's say that we had 650 grams, and I want you to convert that into pounds. Say it again. There's no rate in this class as well. Is that what you're asking? Yeah. Yeah. All right, so it looks like most of y'all got it, which is awesome. We got our conversion factor that we got from our equality, the relationship between pounds and grams. We set up our two conversion factors. I'm going to pick the one over here because that'll allow grams to be on the bottom to be canceled out and pounds on the top. Whoops. All right, punch that into my calculator. I get 1.43301, whatever. All right. My units, grams cancel out. I'm left with pounds. That was the whole idea. And then lastly, my sig figs. 2 sig figs. So 650 has 2 sig figs. Why not 3? Why doesn't that 0 count? No decimal in the number, right? So yeah, this only has 2 sig figs. Okay, and this conversion factor is exact. No, so be careful. This is one of our conversion factors that does not, so I'm going to have to take into account, it's got a bunch of digits, so usually it's not going to limit me, but I do have to still pay attention to it. It is not an exact conversion factor. It might limit me those 5 sig figs, all right? In this case, it doesn't, right? Most conversion factors have a lot of digits, but nonetheless, for being extra special careful, we're going to take into account those 5 sig figs, all right? So 2 versus 5, our final answer should have 2 sig figs. Cool? All right. There are a few, I could throw a few more curveballs at you here, are more complicated unit conversions. Okay, so everything that we've been doing up until this point have just required a single step unit conversion. Grab one value from the table, then you're good, all right? I can make this a little bit more difficult. The easiest way to do so would require a multi-step conversion. All right, so for example, if I wanted to know what 4.3 feet was in centimeters, I wouldn't be able to do that just in one shot. All right, if we go to our table here, get rid of a bunch of this. Just want to make some room for myself here, all right? If I go to my table here and I look carefully, I see inches, or rather I see centimeters, I see feet. I don't see anything that relates feet to centimeters all in one line, right? So there's no way for us to go from feet to centimeters in just one shot. Instead, I'm going to have to chain together multiple conversion factors, all right? So what we got to do is we got to find a path through these units here that will take us from feet to centimeters, all right? Does anybody see how we could get there? Starting in feet, what could we jump to next? We could jump to inches. I have 1 foot is equal to 12 inches exactly. And then once I'm in inches, where can I go from there? Then I can use my second conversion factor here. So this would be my orange one. And then I could use a second one to get from inches to centimeters. All right, this green one here. All right, and that will require getting both conversion factors in your math. Okay, so if I wanted to set this up, this conversion here, where am I? Okay, I would start with my 4.3 feet. Then I would multiply by that conversion factor, which told me that in 1 foot there are 12 inches. And then I would tack on another one that told me that, my second one, that told me that 1 inch was 2.54 centimeters. Okay? This one was the one that I highlighted in orange. This was the one I got from what I highlighted in green on my table. And I can tell it's set up correctly just like before. Feet cancels out with feet, inches cancel out with inches, and I'm left with those units of centimeters. All right, now, one piece of advice that I have, a lot of students, especially when they're starting out, they love to break up these calculations into a bunch of steps, right? They'll do 4.3 times 12, and then they'll write that answer down, and then they'll take that and punch it back into their calculator and multiply by 2.54. It's just a really easy way, but if you're doing multiple steps, transferring information back and forth, it's really easy to accidentally copy it incorrectly and make a mistake. I do it all in one shot on my calculator. 4.3 times 12 times 2.54, all in one shot, right? All in one line. And then I can look back and look at my calculator, and I don't see a bunch of just random numbers. I see these inputs that I'm looking at on my paper as well. It's just a kind of an easy double check for you to do. Also, good reason to get a scientific calculator and not be married to your iPhone, right? Much easier to see the work that you've done on a scientific calculator. So I'm going to punch this in. I get 131.064. Those units, as I've shown here, cancel out to leave me with units of centimeters. And then my final answer, I'm going to take this, I'm going to round it. 2 sig figs, right? This one has 2 sig figs. What about 12 inches in a foot? That one's exact. And what about 2.54 centimeters per inch? Also exact. So the only thing I have to pay attention to are those initial 2 sig figs. So round this would be 130 centimeters. Remember, we can't leave off that 0 at the end or we change the value of that number. Right? Not 13 centimeters, 130. Okay? So one way I can complicate things, make it multiple steps. Require you to grab more than one conversion factor, and then you got to find a path to get from beginning to end. Okay? Another way that I can complicate things is to use mixed units. Okay? One of the more, the one that we're going to be introduced to first here for mixed units, although we'll see this quite a bit throughout the course, is density. Density is a substance's mass divided by its volume. Density is characteristic to a particular material. So air has a specific density, water has a specific density. That density is true no matter the size of the sample that you have, but it is different between materials. Okay? And since this is mass over volume, density is typically measured in something like grams over milliliters, right? Mass over volume. Okay? So if we go to our constants page here, down at the bottom, we can notice that we have a bunch of densities. All right, it tells us for whatever our particular substance is, aluminum, we see that we have a density of 2.710, and the units there for all of our densities on this table are grams per mil. Okay, so let's just take this and use it as an example, 2.710 grams per mil. Dang it. And we're going to convert this into pounds per liter. This is another example of a multi-step conversion because I need to convert the grams to pounds and I need to convert the milliliters to liters. I'm going to have to do both of those conversions here. But the real trick is going to be how we set this up in our math. All right? Before, we always said we're going to start with what's given all by itself. And we're going to do the same thing here, but we need to pick apart these mixed units here. All right? So rather than writing it as 2.710 grams per mil as we did here, we're going to split it up so that it's 2.710 grams over 1 milliliter. All right? We want to, and we're going to do this over and over and over again. We're going to introduce molar mass here soon. We're going to use that so much throughout the semester. Another mixed unit. We always want to split those mixed units. All right, what it means to be 2.710 grams per mil is that there are 2.710 grams in 1 milliliter of that substance. That's what that means. And now we get to play the same game that we've been playing over and over again, where we're going to pick our conversion factors and line them up such that our math cancels out, right? So we're going to need 2 of them here, and it actually wouldn't matter which order we did them in, but we're going to multiply the one where we get to convert from grams to pounds, and then another one where we convert from milliliters to liters. And I've stacked this in such a way that grams cancel and my milliliters cancel. All right, so take a second and see if you can't fill in what's missing here in order to perform this multi-step conversion using these mixed units. All right, so I got my conversion factor from pounds to grams. Again, I need grams to cancel out, so grams is going to be on the bottom. And then I got my milliliter to liter conversion factor. I got this from my SI prefix portion of our table here, right? So now I'm mixing these 2 different conversions that we've talked about, unit conversions and prefix conversions. Again, the 1 goes with the prefix, right? And this time I put milliliters on top so that it would cancel out. Punch that into my calculator, and I get 5.974558, blah, blah, blah. Okay? Cool? All right. Importantly here, I didn't really say this initially, so let me just be clear. We have 2.710, and then we have 1 over 453.59. That means when I punch this into my calculator here, I say 2.710 divided by 453.59, because it's on the bottom of that divisor, right? And then divided by 10 to the negative 3. That's what I'm punching into my calculator, okay? Because again, it's underneath these divisor signs here. All right, we got our units. Again, what we're left with is pounds over liters. Elbs on top, liters on the bottom. And then my last step here is going to be to round to 4 significant figures, right? This one has 4 sig fig. Why do I count that 0? Because the decimal in that number, right? And then this one has 5. So I'm limited by that initial measurement. This one's exact. So my final answer here, 5.975 pounds per liter. Okay? I will also say that, just to note, the other way that we use density is to convert between mass and volume. So if I had like 50 grams of aluminum, I could tell you the volume of aluminum. And what I would want to do is, in order to build that conversion factor, I would do this exact same step here of splitting up those mixed units and then making sure everything canceled out all nicely. All right? Okay, the last complication that I can throw at you here is when we have units with exponents. All right, so what do I mean by that? Well, we said that we would measure, for example, the length of this table using length units like meters, right? If I wanted to measure the area of this table, I would take the length and multiply it by the width. That would give me the area of this table, which means that my area would be measured in units of meters squared. All right? So let's say, and let's actually use a little bit of an easier one for right now. Let's say that I wanted to convert 4.5 centimeters squared into inches squared. All right. We've done the inches to centimeters conversion before. So, and it kind of looks the same to start out with. We're going to take our 4.5 centimeters. We have this unit conversion that centimeters squared, I'm sorry. We have this unit conversion from our constants page that tells me that there's 2.54 centimeters in 1 inch. But there's a problem. Centimeters squared and centimeters are not the same thing. Those do not cancel out. All right? If I just did this, I'd cancel out one of them and I'd be left in units of centimeters times inches, which is just nonsense. All right, so how are we going to get rid of the centimeters squared? Well, what we're going to do is we're going to take this conversion factor. We're going to take the entire conversion factor and we're going to raise it to that same exponent. Right? Raise it to that same power of 2. That squares not only the units, but it also squares the numerical values inside of there as well. All right? So what we're going to do here is we're going to take that entire conversion factor and raise to the power of 2. Okay, which means that when I punch this into my calculator, I'm going to need to punch into my calculator 4.5 divided by 2.54 squared, right? I got to square everything inside those parentheses there. Okay, this would leave me with 0.697501. And my units now are inches squared. All right, if I'm going to round this to the correct number of sig figs, I should have 2 significant figures. So 69 becomes 70, so 0.7 inches squared What's wrong with that? I need 2 sig figs in that answer, right? So I can't just put 7. I got to put 7, 0. Boom. Final answer, put a box around it. All right? So areas are measured in square units. You could also measure volume in cubed units. So if you have units that have these exponents associated with them, that's how you're going to deal with that. You have your regular old conversion factor, and then you're going to raise it to that power. Cool? All right. Let's go ahead and take a 10-minute break. And so we'll meet back here at 45 after.